Welcome to West Virginia, and it really is West Virginia. Okay, so in our glorious state, we love Joke of the Day because Joke of the Day is the best part of the day. Are you ready for Joke of the Day? I sure am. So, what kind of shoes does a thief wear? Sneakers, of course. Okay, let's sneak our way into looking at how to divide polynomials, also called factoring polynomials. Now, the first type of factoring that we're going to look at is the simplest type of factoring called common monomial factoring. Now, in order to do common monomial factoring, we need to understand what a common monomial is. In other words, the greatest common factor, lovingly called the GCF. The greatest common factor is more or less what it sounds like. Greatest means biggest or largest. Common means it occurs frequently. And factors are things that are multiplied together. So in other words, the greatest common factor is going to be the biggest term or the biggest factor that is common to all of the terms or all the monomials. So it's the largest number and variable combination that can be divided out of each monomial. So let's take a look at examples so this will make more sense. In our example, we've got three monomials here. We've got 16a to the fifth, m to the first, negative 12a to the third, m to the third, and 4a squared m to the fifth. And we want to find the GCF, the greatest common factor for all three of those monomials. So what we're going to do is we're going to look at those coefficients and we're going to say, okay, the coefficients 16, negative 12, and 4, what is the largest number that I can divide out of all three of them? Well, I can certainly divide this by 8, but this is not divisible by 8. This is also divisible by 4, and if I'm not sure how to figure that out, I'm going to break that into its factors. 2 times 8, 8 is 2 times 4, and then 4 is 2 times 2. 12 is 2 times 6, and 6 is 2 times 3. And then 4 is simply 2 times 2. So I'm going to look at each of the ends of these factor trees here, and I'm going to say what's common to all of them. Well, all three of them have a pair of 2's, a pair of 2's, and a pair of 2's. So the GCF for the coefficients of each of these monomials is going to be 2 times 2, which is 4. So my GCF then for the coefficients is going to be that 2 times 2, which is 4. Now I'm going to look at each of the variables themselves. The a to the fifth, and then the a to the third, and then the a to the second. And I'm going to say, what's the largest number of a's that I can divide out of each one of those? This has 5 a's in it, this has 3 a's in it, and this has 2 a's in it. So the largest number of a's that I can divide out of all the terms, all the monomials, is that a to the second. In other words, 2 a's can be divided out of every single one of them. And now I'm going to look at the m's. And so I've got my m to the first here, I've got my m to the third here, and I've got my m to the fifth here. And as I look at all three of those m's, I'm going to say, what's the largest number of m's that I can divide out of every one of them? I can divide 1 out of here, this has 3, and this has 5. So the biggest number of m's that I can divide out is one single m. So here is my GCF, 4a squared m to the first. Now, being able to identify that GCF is going to be very important for doing common monomial factoring, because all that common monomial factoring is isolating or dividing out that greatest common factor from each individual term in your polynomial. So before we get into A and B, let's take a look at some examples here of what this common monomial factoring looks like. So in my first example, I'm going to take a look at that 10x plus 30. There are two terms in there because recall, terms are separated by addition and subtraction. So I've got one term here. There's the addition separating out that second term. Now what I'm going to do is look at each one of those and find the largest coefficient that I can divide out as well as the largest variable that I can divide out. It has to come out of both of them. So as I look at the coefficients of 10 and 30, the biggest number that will divide into both of them is a 10. So I'm going to divide that 10 out of each term. And when you do common monomial factoring, you need to remember it has to divide out of every single term. Now, this one has an x, but this one doesn't have an x. I have to be able to divide that x out of both terms. It'll only divide out of this one. So therefore, I cannot divide it out. So what I'm going to do now is actually do that division. In other words, 10 divided by 10, or 10x divided by 10. 10 divided by 10 is 1, but I'm left with an x in there. And then here, 30 divided by 10. Well, positive 30 divided by 10 is positive 3. Now the problem is, I do not want to change the value of the expression. I only want to change what it looks like. And when I converted my 10x plus 30 into an x plus 3, I completely changed the value of the expression. I don't want to do that. I simply want to change what it looks like. So that 10 that I divided out, I have to actually keep it in there so that I don't change the value. So to keep it in there, what I'm going to do is I'm going to reverse that division, and I'm going to let it sit out front, and I'm going to put a parentheses out like this, because if this is what you saw, what would you do with that? Absolutely, you would distribute that 10 through. So when I distribute the 10 through, I do 10 times x is 10x, and 10 times 3 is 30. That takes me back to the beginning. So this is my factored form because the term factor indicates things that are multiplied together. Matter of fact, let me go ahead and write that over here. Let me write it in the beginning, actually. That's a great place to put it, back in the beginning. And then that leads me to these two notes that I want to make right here. Recall that factors, and I did not do a good job here with my, my outline form, but a factor, I'll just put it right here. Factors are things that are multiplied together. Things multiplied together. Factors are things that are multiplied together. Very important that you understand that, because that's going to guide you through the rest of this, all of these lessons about factoring. So going back here, when I do that common monomial factoring, hopefully what you noticed is that once you did the factoring, you are looking at the distributive property. So therefore, that common monomial factoring, what it does is it reverses your distributive property. And that's helpful because it allows me to check and make sure that the factoring that I did is actually right. Because if I can distribute my factor that I pulled out, if I can distribute it through and get back to the beginning, then I know without a doubt the answer that I've written is correct. As long as I factored out the largest coefficient and the largest variable that I can divide out. Now, we'll come back here to part B in just a minute. Let's continue on with these examples. So knowing what we know now about that common monomial factoring, what I'm going to do in the second one is, once again, I have two terms because they're separated by addition and subtraction, one here, one here. I'm going to look at each of those terms. I'm going to look at their coefficients. There's an understood coefficient of 1 here and the coefficient of 6. The largest number that I can divide out of both of them is a 1, and division by 1 really doesn't help. So I'm not going to do that. Now I'm going to look at the variables. This has 2 x's in it. This has 1 x. What's the largest number of x's that I can divide out? One single x. So I'm going to divide that x out. And like I said, I'm actually going to do that division. When I take an x squared and divide it by x, there's those laws of exponents that say when you divide the bases and the bases are the same, remember you subtract those exponents. So 2 minus 1 will give me 1, so I'm left with one single x. And then when I do this division, these x's will cancel out and I'm left with a positive 6. But recall, I don't want to change the value of my expression that's written in black. I only want to change what it looks like. I just want to change the format, that's all. So the x that I divided out, I'm going to let it sit out front. I'm going to write down in a parentheses what is left when I do that division. And recall that I can check this factored form to make sure that it's right. Just simply distribute that x through. X times x is x squared. X times 6 is 6x. Yes, it takes me back to where I started, so I know that these factors are correct. Largely because, one, I can get back to where I started, but also because I know that I divided out the largest thing that I could divide out. So let's take a look at another example. In this one, again, I have 2 terms. So here's my first term with the 20y squared. Here's my second term with the plus 15. Now I'm going to look at those coefficients, 20 and 15. I'm going to say, what is the largest number I can divide out of both of them? Yes, they are both divisible by 5. Now I'm going to take a look at the variables, 2 y's here, no y's here. Recall, what I'm dividing out has to come out of both of those terms. So I have to be able to divide y's out of both of these terms in order to actually make it happen. Since I can't divide y's out of both of them, I'm not going to do it. So now I'm going to do the division, and I'm going to write down what's left. 20y squared divided by y, well 20 divided by 5 is 4, and I'm left with 4y squared because I didn't divide any y's out, and 15 divided by 5 is 3. And once again, because I do not want to change the value of my expression, only what it looks like, what I divided out, I'm going to let it sit out front outside of that parentheses. And that is the largest factor that I can divide out of these terms. There's nothing more that I can divide out, and I can check and make sure it's right. 5 distributed through, 5 times 4y squared is 20y squared. 5 times 3 is 15. I can get back to the beginning so I know that it's correct. All right, let's try a couple more. So in this one, yet again, 2 terms. So I've got a term sitting right here and a term sitting right here. Look at those coefficients, 28 and 14. What is the largest number I can divide out of both of them? Now some of you immediately are going to say 7. And let's go ahead and go with that 7. Now some of you are having a little heart attack right now going, no, there's something. Hang on, I'm going to prove a point here to you. Now, I can divide c's out of here, but I cannot divide c's out of here. So I'm not going to divide any c's out. I can divide 1d out of here and 5d's out of here. So I'm going to divide 1d out of both of them because I need to divide it out of everything. So now I'm actually going to do that division. And when I take that 28 divided by 7, I get a 4. And I didn't divide any c's out, so I'm left with c squared. But these d's are going to cancel. Now here, negative 14 divided by 7 is negative 2. And then d to the 5th divided by d to the 1st. Once again, subtract those exponents. 5 minus 1 will give me 4. I'm left with d to the 4th. And what I divided out, recall, I'm going to let it sit out front outside that parentheses. Now remember, I mentioned up here, and I actually didn't mention it here, but I should have, there's nothing more that I can divide out of this x and this 3. There's nothing more that I can divide out of this x and this 6. There's nothing more that I can divide out of the 4y squared and the 3. But as I look at this, there is in fact more that I can divide out. Because I look at the 4 and the 2 of coefficients, both of them are divisible by 2. So I'm going to go ahead and keep on factoring. Just keep factoring, factoring until you can't factor anymore. There's a shout out to Dory from Finding Nemo. Anyways, I'm going to divide that 2 out of both of these. So when I do that division, 4c squared divided by 2, well 4 divided by 2 is 2, and I didn't divide any c's out. 2 divided by 2 is 1, and I didn't divide any d's out. But recall that whatever I divided out, I let it sit out front because I don't want to change the value. So that 2 that I divided out, I need to slip it out front. The problem is, how am I going to combine it with that 7d? Well, recall that this, I could check by the distributive property. Distribution is multiplication. So when I slide this out front here, I'm going to multiply the 2 and the 7d together, giving me a 14d sitting out front. This is the correct factored form. This, what's written in blue, is almost there. It's just I needed to do some more factoring. Now notice that if I distribute my 14d through, 14d times 2c squared, 14 times 2 in fact is 28. D times c squared is a c squared d. 14d times negative d to the 4th is a negative 14d to the 5th. So I can get all the way back to the beginning. I need to get all the way back to the beginning. If you can't get all the way back to the beginning, you've got something wrong. So this is the correct factored form. So those of you who were having that little heart attack when I said, let's go ahead and divide that 7 out, and you were thinking, no, take a 14 out. You're right. If you would go ahead and take that 14 out here in the beginning, you would get right down here in one step. But I wanted to go ahead and go with the 7 to just mention and just point out to you that if you're somebody who says, I'm struggling with my multiplication tables, I'm struggling with find those numbers that will go into these. So what you're going to do is you're going to go ahead and pull out what you can. Go ahead and divide through by that 7. But then look at what's left in the parentheses and just keep factoring until you cannot factor anymore. So this is the correct factored form. All right, let's take a look at just a couple more. So here, notice I have 3 terms. We've not seen that yet. But what I'm going to do is continue with this idea that I'm going to make sure that whatever I divide out has to come out of every single term. So it has to come out of all three. So I'm going to look at those coefficients of 18, 6, and 15, and I'm going to say, what's the largest number that will come out of all three of them? Sure, this and this are divisible by 6, but the 15 is not divisible by 6. So I have to find a number that will divide into all three of them, and that is a 3. So now what I'm going to do, and I have made a mistake. There needs to be a y right back there. There we go. Okay. Now I'm going to look at those y's. There's 3 here, 2 here, 1 here. What's the largest number of y's that will come out of each and every term? Yes, one single y. So I'm going to divide that one single y out of each and every term, and now I'm going to do that division. 18 divided by 3 is 6. Y to the third divided by y to the first is y squared. Negative 6 divided by 3 is a negative 2. Y squared divided by y is y to the first. Negative 15 divided by 3 is a negative 5. And the y's here will cancel. But recall, if I'm saying this is my answer, it does not have the same value as what I started with. So whatever I divided out, I need to write down out front and put a parentheses around it. There's my factored form. And yes, I can check this because 3y times 6y squared is an 18y to the third. 3y times negative 2y is a negative 6y squared. 3y times negative 5 is a negative 15y. And I can check inside this parentheses and I can say, okay, there's nothing more that I can divide out of each and every term, so I know that this is the correct answer. All right. So in the next one, same idea. I'm going to look at every single term and I'm going to say what's common that I can divide out of each one of them. So I've got 3 terms, 1 here, 1 here, 1 here. Look at those coefficients of 18, 12, and 24. What is the largest number that will be divided into each one of them? That's going to be a 6. Each one of them is divisible by 6. Now I'm going to look at those x's. X to the third here, x to the third here, x squared here. What's the largest number of x's that I can divide out of each and every term? Well, I can divide 2 x's out of here, here, and here. Now let's look at those y's. I've got a y squared here, y to the first, y to the first. What's the largest number of y's that will come out of each and every term? And it is a y to the first. So now I'm going to do that division, and when I do that division, and boy am I running out of room right now, so I'm going to actually slip it right up here. I don't think we need this one anymore. Let me just put that one right up above it. There we go, so I'm not crowding myself out. 18 divided by 6 is 3. X to the third divided by x squared is x to the first. Y squared divided by y is y to the first. Now here, negative 12 divided by 6 is negative 2. X to the third divided by x squared is x to the first. These y's will cancel. Negative 24 divided by 6 is a negative 4. X squared divided by x squared cancels. Y divided by y cancels. I'm just left with that negative 4. And recall, I don't want to change its value, just what it looks like. So I'm going to write down out front what I divided out. And here is my factored form. Notice as I look at these 3 terms, there's nothing that I can divide out of all 3 of them. So I've divided out the largest factor that I can possibly divide out. And when I distribute it through, 6x squared y times 3xy, sure enough, is 18x to the third y squared. 6x squared y times a negative 2x, sure enough, is a negative 12x to the third y. And then 6x squared y times a negative 4, sure enough, is a negative 24x squared y. So that is the correct factored form. Now, one last one. Notice here that with these 2 terms, as I look at those coefficients, there is nothing common that I can divide out of those coefficients. This is divisible only by 5, but 5 won't go into 12. This is divisible. I can take x's out of here, but I can't take x's out of here. So there is nothing common that I can divide out of each and every term. And recall that if I'm going to do it, it has to come out of every single term. So now what? Well, there's a couple of ways that I can express the answer. I can simply say can't be factored, and that's good enough. Can't be factored. But honestly, a better way to express this is to do what we say, call it prime. Because prime numbers are numbers that cannot be factored into anything other than 1 and itself. For instance, 7 is a prime number. Because if you take a look at 7 and you try to create a factor tree out of it, 7 can only be broken into a 1 and a 7, which doesn't help at all. 11 is another prime number because it can only be broken into a 1 and an 11. So prime numbers are numbers that can only be divided by 1 and itself. In other words, it can't factor into these beautiful factor trees. Same thing with polynomials. If they cannot be factored, then we simply say that they are prime. So like I said, certainly I can say right here that the polynomial can't be factored, but a much nicer, more technical, beautiful mathematical way to say it is just call it prime. So hopefully this helps you to understand how to factor polynomials with the greatest common factor, and that simply means the largest factor, the largest coefficient that you can divide out of every single term, and the largest variable that you can divide out of every single term. I hope that helps. Have a great day.